first part of section 4.7, completing the square. To start out with, go ahead and pause and write down some of the steps for solving quadratic equations by finding square roots. The first one, we're going to keep it the way it is, and I'm going to write it as a binomial squared. Now first, if you need to, go ahead and double bubble. You'll see it's going to be x and x, factors of 16, that'll give you 8 or 4 and 4. And they're both going to have to be negative, so I get a minus 8, and when I multiply I get a positive 16, and that equals 25. Now, this can be rewritten as x minus 4 squared equals 25. Now what we're going to do is take the square root of both sides since I have something squared. Once I do that, I've got x minus 4, because the square root and the squared cancel each other out, equals, remember anytime you put the square root in, you need to put a plus or minus on the side that doesn't have the x. And now the square root of 25 is 5. Now to solve for x, we add 4 to both sides. So I end up with x equals 4 plus or minus 5. That I can actually work out, so I'm going to go ahead and do both. I've got 4 plus 5 is 9. 4 minus 5 is negative 1. So those would be my two solutions for x. Another example, go ahead, if you need to, double bubble this right off the bat. When you double bubble this, you will end up with 2m in the front. Notice I'm taking the square roots of these, and it'll be 9, so that'd be the square root is 3. And since I need a negative 12 in the middle, this sign has to be minus. So it's going to be 2m minus 3 squared equals negative 8. And again, now I can take the square root of both sides since I have something squared. When I do that, the square root and the squared cancel each other out. We're left with 2m minus 3 equals, remember the plus or minus. Now this negative tells me I need an I, and 8 I can break up into 4 times 2. So if we think of the square root of 8 as the square root of 4 times 2, the square root of 4 is 2, so I'm going to put that 2 right in front of the I. So it'd be 2i, and then I have square root 2 left over. Now what I'm going to do is add 3. So I have 2m equals, remember we put the 3 first, plus or minus the 2i square root 2, real part plus or minus imaginary part. Now we divide everything by 2. And for this problem, it really is a lot easier if you divide both of these by the 2, and you'll see why, because this is going to take care of some math right away for you. I'm going to just keep that as 3 halves, plus or minus. Now here, these 2's factor out, or they become 1, so it would be 1i square root 2, so it's just going to be I square root 2. So that would be the solutions for this problem. We always put the I in front of the square root because if we put it at the end, it looks like it's underneath that square root symbol. So that's why they always put the I in front of the square root. Now go ahead and pause so you can find the next set of directions for writing expressions as the square of a binomial. The first thing we need to do is figure out what C would be in order to make this a perfect square trinomial. So what we need to do is take half of this B. So what I'm going to do is I'm just going to write this out, negative 12 divided by 2, and then we square it. So C is going to be negative 6 squared, and anytime you square a negative or a positive, your answer is positive. So now as a perfect square trinomial, this would be x squared minus 12x plus 36. That's the first part of your answer. Then what you need to do is factor this, and that's going to end up being a binomial squared. If I take the square root of x squared, that would be x, so that goes here. Square root of 36 is 6. And since I need a negative 12 in the middle, this is going to have to be a minus 6. So that would be written as a binomial squared. If you were to write this out, x minus 6 times x minus 6, you would get back to this. Okay, so that's the factored form. Let's do another one. C equals negative 23, that's b, divided by 2, and then we square it. When I square this, I end up getting 529 on the top. Negative 23 squared is 529, and it'll be over 4 because 2 squared is 4. So when I rewrite this as a perfect square trinomial, I will have this with my new answer in there for C. That's the first part of my answer. Now when I write this as a binomial squared, I'm going to have x here, it's the square root of this, and it's the square root of this. Now if you really think about it, since this number right here is squared of this number inside the parentheses, really this all has to be minus 23 over 2 squared, because the square root of 529 over 4 is going to go right back to negative 23 over 2. So that is the answer as a binomial squared. Same thing happened over here. This minus 6 is what we had in parentheses before it was squared. In order to find C, I have to take negative 2/7 divided by 2 and square it. And since we have a fraction, I'm going to change this to negative 2/7 times the reciprocal of 2, which is 1/2. And then I'm going to square that. Okay, these are going to factor out, so I end up having negative 1/7 squared. So now when I write this out as a perfect square trinomial, I rewrite everything and I throw in my new C, which is going to be 1/49. So this will be plus 1/49. That's the first part of my answer. I found C. Now if I write this as a binomial squared, it's going to be x minus, because of this minus sign here, and then inside here is 1/7. So it'll be x minus 1/7 squared. So that is my binomial squared. This number here is a couple different things. It's the square root of that. It's what's in the parentheses before you square it when you're finding C. Or you could even take half of that. Half of negative 2/7 is what goes in the parentheses. Now take a second, pause, fill in some blanks. This is how we're going to solve by completing the square. The first thing we want to do in solving this problem is to get all the constants on one side and the variables on the other. So the first thing we're going to do here is subtract the 12v. So I'm going to line the v's up. And I'm also going to subtract 200 so that all the constants are together on the other side of the equation. So I'm going to end up with v squared minus 29v. This is gone now, but I'm going to leave a blank here because I need to find c just like in the problems we just finished. And then over on this side, I'm going to have negative 243. And again, we're going to leave a blank here. Now I'm going to go off to the side and I'm going to figure out what c is supposed to be. We're going to take b, so that'd be negative 29 over 2 squared. Negative 29 squared is 841. 2 squared is 4. So what I need to do here is I need to add the c So it's going to be plus 841 over 4 plus 841 over 4. Notice I had to add it to both sides. If I'm going to add something to one side to make it a perfect square trinomial, then I also need to add that number to the other side of the equation. Okay, so now I'm going to write this as the binomial squared, which will be v minus, and remember it's what we had in c before we squared it, so it'll be 29 halves squared. This whole thing is equal to this. Now we have to do some addition. Negative 131 over 4. That's what this math works out to be. So now that I have a binomial squared, I'm going to take the square root of both sides. Okay, take the square root of both sides. Then on the left, we end up with v minus 29 halves equals plus or minus, and then this here tells us there should be an I, and then it's going to be the square root of 131 over square root of 4, which is 2. Now I add the 29 halves. So v equals, I'm going to write the 29 halves first because that's the real part, plus or minus I square root 131 over 2. And with this, because it is a fraction, you could put the I at the end. Either way would be totally fine. This is our solutions for v. Another example. Again, we need to get the variables on one side, so I'm going to subtract r, and I'm going to end up with negative 4r squared plus 20r equals 13. Now I did not leave a space yet because I need to have a 1 in front of the r squared. So I'm going to divide everything by negative 4. Remember, when you divide one thing by negative 4 in an equation, you have to divide everything. So we've got r squared. That turns into minus 5r. Now I'm going to leave a space here. Equals negative 13 fourths. And again, I'm going to need some space. Now I'm going to go off to the side and find c. For this one, our b is negative 5, so it's going to be negative 5 divided by 2 squared. Again, whenever you square a negative, it's always positive. So if I take 5 squared, that's 25. 2 squared is 4. So I need to add 25 fourths to both sides of this equation. Now when I go to this side and I write it as a binomial squared, it's going to be r, and then think back to what we had in the parentheses up here, minus 5 halves, r minus 5 halves squared equals, and that's going to be 12 fourths. We also know that as 3. So if you want to, you could rewrite this r minus 5 halves squared equals 3. Now that we have our binomials squared, I'm going to take the square root of both sides. And then we do the rest of the math. We've got r minus 5 halves equals plus or minus the square root of 3. Now we add 5 halves to both sides. And we end up with r, this cancels out, equals, I'm going to put the 5 halves first, and then plus or minus the square root of 3. And there's our solution for that problem. Notice this time we didn't even end up with a complex number. And that's going to conclude section 4.7 for now.